Hey everybody, today I will do the hands-on part on the circuit that we did last time. We did a series parallel circuit, and this is the circuit here. So you got the voltage source, and we got R1, resistor number 1 was 8.7 volts, and resistor number 2 and 3 was 3.7 volt each, right? And the total resistance was 3.8 ohms, and the Turner current was 2.63 milliamps, right? So the first step is going to be um, to obviously to do the circuit, but in this case I already have it done because I want to save some time. But I want to explain um, which one the resistors, how they are connected. All right. Here you can see I got a positive and I got a negative side of the circuit, right? And as you can see right there, all right. So that is the power source right there, right? So which is basically it's going to be this one. It's going to be those two leads coming up right there, right? Red to the red and black to the green right there, right? Positive, this is a positive, this is a negative, right? So that's why you see here on the voltage source you have a positive and a negative side of the voltage, I mean of the circuit, right? Okay, so this is resistor number 1. Resistor number 1 is connected to the positive, right? To the positive side. And then resistor number 2 is connected to the positive side and the negative side, right? And resistor number 3 is also connected to the positive side and the negative side. And also this technically this is connected to the negative side too because it's going around. This is a complete loop here, right? But again, this is resistor number 1, resistor number 2, and resistor number 3. This is 3.3 kilo ohms. This is 1 kilo ohm each, right? So the step number 1 will be to see if we can get the resistance, the total resistance, right? So that will be step number 1, right? So to measure resistance, I got this cheap multimeter that I got it from Harbor Freight for $7. Okay, so I want to go ahead and turn that one on and put it into 20 kilo ohms, right? Okay, so now to measure the resistance, you always making sure that the circuit is not connected to the power source, right? Again, let me say this again. To make sure the resistance, you make it sure that the circuit doesn't have any power on it, right? Okay, so as you can see that to measure the resistance, I will have to measure from that point and to this point, right? From resistor number 1 to resistor number 3. That will give me the total resistance of the circuit. So, and when you do the resistance, you don't have to. You can actually do negative and positive. It doesn't really matter what. If you can put the negative on the positive side and vice versa, it doesn't really matter, right? So, okay, so let's do. Okay, let's do this. Okay. Okay, are disconnected. Making sure they're connected. Okay. Try this again. Here you go. Here you go. Alright? So the resistance is 377 ohms. Sorry, kilo ohms. 3.77 kilo ohm. 3.77 kilo ohm, which can be round to something is loosey. It's not giving. It's giving something different. Here you go. Yeah. So that can be round to 3.8. I mean, I go with the value. All right. 3.77 ohms. That's what we got. Yep. 3.77 ohms. Okay, cool. 3.8, very close to 3.8 ohms. Sorry. Okay, now let's do the voltage, right? So to do the voltage, I had to apply some power on it. Okay, as you can see, I got it set up at 10 volts, right? And I want to go ahead and connect the positive lead to the red and the negative, and the black to the negative lead, which is the green here, right? So now to do the voltage, I will have to change the voltmeter to volt DC. We're doing DC current here. So you don't want to do this type of experiment with AC current, right? It's dangerous. So we're doing 10 volts, so I can go with 20 volt DC to get some reading. Okay, so let's measure the voltage at resistor number 1. Okay, and you can see 8.7, right? And we got 8.7 volts in there. So that's correct, right? Now let's do at resistor number 2, right? 1.29, 1.29. .29, right? So that's pretty close. We got 1.3, right? That's pretty close. 1.3, right? So let's do resistor number. That was resistor number 2. Let's do resistor number 3. Here you go. 1.29 again. Resistor number 3. Okay, so it's close, right? Very close. And the reason why we're not getting the exact values is when you do the math, when you do the calculations, when you do these calculations, the hand calculations, it's easy to get more accurate numbers, right? When you do the hands-on part is when it's when the problems come in, in place, because you might get like loose wires in the circuit, and and then you got some certain tolerance for the resistance. Each resistor has some certain amount of tolerance. So here you go. So basically, that's the downside of when you're comparing hands-on calculations with actually measure values, right? So when you measure the values, usually you get a plus or minus. That's why there is a range of plus or minus error when you do this, because you have a certain percentage of tolerance on each resistance and on each resistor, right? Okay, so now we have that, right? Now let's do number. So we did the voltage, right? We did the resistance, we did the voltage. Now let's do the current, right? To do the current, we have to break the circuit, right? We have to break the circuit. And to break the circuit, we actually have to pull this out. Okay, so I pull out resistor number 1 because I want to measure the current between resistor number 1 to resistor number 1, right? Because technically that's the whole current going through that resistor, that resistor right there, right? So I need to pull that one out, and I will stick this wire right where that resistor came from, right there in the same bus, right? Then I will set my multimeter to current, right? So I will set my multimeter to current, and I will touch the resistor and the wire. Here you go. 2.63. Okay, so we got the values. 2.63 milliamps. Yep, 2.63 milliamps. Yep, I go with that, right? So we got the current is correct, right? So we had in the calculation we have 2.63 milliamps, and that is exactly what we got in the measure value, right? Now let me put that resistor back there, and let me pull resistor number 2 out, right? Okay, and let me stick that wire where this bus right here, where resistor number 2 came from. Okay, so now I need to measure the value on the current on resistor number 2. Here you go, 1.31, right? 1.31. All right, and then this resistance should be the same too, because the sum of this so this one was 1.31 milliamps, right? The current over here in this resistor number 3 is going to be around the same value, 1.31 or 1.3, something, because the sum of these two currents right here will equal to the current going on this resistor number 1, right? So let's put it back put it back there, and make sure that it's connected. Making sure that resistor is connected. Okay, so it seems like it is now. Now let's pull that one out and pull resistor number 3 out. So we did resistor number 2, and now let's do resistor number 3. Okay, let me see. Let me see if this is, you seem like it's not. I need to make sure that it has a good connection on it. Okay, so here you go, 1.312, right? So the current on resistor number 3 is also around 1.3, 1.3. I can go with that. So yeah, so here you go, 1.31. Yep. Okay, cool. So we got all the current. We got the current on resistor number 1, number 2, and number 3. Okay, so that's it for this video, guys. I hope you learned something. I hope you learned something in this video, and you will be able to apply it somewhere. Maybe you taking a basic circuit, or maybe you want to do some little projects like this for fun. But here you go, there's a basic series and parallel circuit, right? So we got the power supply here, and that's basically what the little circle is right there. And you got the 2 leads coming in. You got resistor number 1, number 2, and number 3. All right, thank you for watching. I hope you learned something in this video. Thank you for watching.